Okay, so when we are given a limit like this, the first thing that we would naturally try to do is replace x with -3, because that's the fast way to do it, right? So if I try to do it that way, I have to write something like -3 squared plus 3 times -3, all of that over -3 squared plus 9, -9, sorry. So what is that? If I solve this in the numerator, I am getting 9 minus 9, and in the denominator I'm getting 9 minus 9. What is this? 0 over 0. So how do I find the limit? Um, in the previous lesson, in the previous activity, we had infinite limits, right? Remember, when you have 0 in the denominator, you had vertical asymptote, right? And the answer could be either positive infinity, negative infinity, or that does not exist. But if you look closely here, you look carefully here, I have another 0 in the denominator. This scenario is 0 over 0, and this is not solved as we did the previous limits. For the previous limits, we need to have a number that is not 0. We can have 1 over 0, 3 over 0, -5 over 0, and we can solve them. But here it's different because what I'm getting here is 0 over 0. So what I'm going to do whenever I find a limit like this, when I get 0 over 0, is that I will try to remember my algebra and try to see if there's anything that I can factorize in the numerator or the denominator and see if I cancel out something. That's the only way to solve these exercises. In case that I'm not able to factorize anything, then I will say that the limit does not exist. But let's try to do that. Let's try to see this and find if there's something that we can factorize here. For this part, you need to remember your algebra classes because we will use it a lot. In the numerator, I see actually I can factorize something. I have a common term. That common term that I have in the denominator is an x. So I can factor out this x. Multiplying x plus 3. You see? What about the denominator? Is there anything that I can factorize there? Well, yeah, actually. There is a difference of squares, you see? I have a square number, and I also have here a square number. Maybe if I rewrite this like this, it's more obvious that I have a difference of squares, right? Because 9 is the same as writing 3 squared. And what is the difference of two numbers that are square? That is a plus b times a minus b. Just in case you forgot, right? So in the numerator, I get the same, x plus 3. And in the denominator, I'm factorizing this as x minus 3 times x plus 3. You see, I was actually able to factorize something here. And once I factorize here, I can cancel this with this, right? What I am left here is the limit as x approaches -3 of x over x minus 3. What I did here was canceled the terms, and then I got a limit in which I can try to write -3 instead of x and see what happens. In this case, I can actually find a number. This is 1/2, you see? So this limit does have a value, which is 1 over 2, but we were just able to find it because we factorized. Remember, when you get a limit 0 over 0, what you have to do is factorize. For example, here I have another one. Here I have x squared minus 9 over x squared plus 6x plus 9. Again, first, I will try to do it the fast way. The fast way means instead of writing x, write negative 3. So I will write negative 3 square minus 9 over negative 3 square plus 6 times negative 3 plus 9. Okay? And what is the answer to this? And the numerator is 0. And yeah, in the denominator, this is also 0. Okay? So once again, we're falling in the same situation where we have both numerator and denominator as 0. And in that case, what we have to do is just the same we just did. We have to try to look and see if there's something we can factorize and hopefully we can cancel something out. Yeah, actually in the numerator I have a difference of squares again. So I can rewrite this as the limit as x approaches negative 3 of x squared minus 3 squared over x squared plus 6x plus 9. I will write this as 3 squared again too. In the numerator, the factorization that I can apply is the difference of a square, which is x minus 3 times x plus 3. Okay, what about the denominator? You look closely, this is a perfect square trinomial. So I can factorize this as a binomial square, that is x plus 3 squared. And here again, you need to remember your algebra classes if this is not making any sense. What I did here is a squared plus 2 times ab plus b squared. This is a perfect square trinomial that is factorized as a binomial square. Okay, that is a factorization that I did there. And yeah, if I write it that way, I will be able to cancel out something here. I can get rid of this x plus 3 in the denominator with this square here. And then my expression looks something like this, right? I got the limit as x approaches negative 3, x minus 3 over x plus 3 here. Now, I have this limit with less terms. I will try to find it again, replacing negative 3, and see what happens. I get negative 3 minus 3 over negative 3 plus 3. Here, I have negative 6 over 0. You see what happened in this case? In this scenario, what happened again is that I still have a 0 here. So when this happens, I will say that the limit does not exist. You see?